He's lovely, man. He's lovely. And guess what? With just $2 you can get this done.
Hello guys, welcome once again. In this video, I'm going to walk you through on how I designed what you saw in the demo. Pay attention, don't skip any parts, and the favor you will do for me, I'll be grateful. This for the channel to grow. Subscribing, sharing to your students, even if it's not beneficial to you, and I promise to deliver a lot on this channel. Regardless, the channel just started, it is loaded. Stick to the screen as I walk you through. Okay, no more guessing. You just want to design such a system, say, the one I saw on Wigatronics, or just blinking the way I want it, I love that. You may decide to do your own that it will be blinking this way, let's say, welcome, welcome. Just this teaching now will give you how to tweak the whole thing, whatever you want to design, you get it by your calculation. Okay, is that general question that my students asked and all that. I decided to make the video for them. They asked where is the 0.693 coming from in this formula we normally use for 5 timer IC. Okay, it's actually coming from the RC charging equation as RC charging equation, um, capacitor charging equation of 5 timer IC, and the value you have is actually the equivalent of natural logarithm of 2 because the capacitor in 5 timer IC is charges and discharges 1/3 and 2/3 respectively, in the sense that if we supply 12 volts to a 5 timer, the charging is from 4 volts to 8 volts and discharging is from 8 volts to 4 volts. So it's just like two reversing processes, in the sense that where charging stops is where discharging begins, and where discharging stops is where charging begins. I just is called unstable. It doesn't stop except power is removed from it. Unstable. It is not stable in any state. Okay. Other facts you need to know from what you have there, you need to know that it charges from um, 1/3. The common voltage we supply is V6, but I just want to tell you that the IC is IC, the data sheet. So one thing is that any IC you want to use, go to the data sheet. You can hand up to what I just mentioned before. You can also use 5 volts to work your design. Like the video you saw in the demo, the welcome design, I used 5 volts. So, but I wanted to elaborate the explanation. You now know that you may not you are not restricted to just 5 volts. So, all right. Now, here is the equation you need to know that the total period here is into this form. And when we say period, we are combining both the on state and the off state to have what we call period. And the general formula it takes is 0.693 into R1 plus 2 times R2, all in brackets multiplied by the capacitor value. I note that R1 is the note very, very important. Note this very, very important thing. R1 is the resistor between pin 7 and pin 8. R1 is between pin 7 and pin 8. In case someone brings a design just to test your knowledge and decides to label any resistor between 7 and 8 as R2 and label the one between 7 and 6 as R1, you will tell the person right there that, okay, your labeling is wrong. This is how it should be. And for that to work, you need to use this formula, because if you use this formula with wrong labeling, you get the wrong result. What your system will be doing, it will be giving you the output for off as on and the output for on as off, which is not what you want. So stick to what I'm telling you here now. R1 is the one between 7 and 8, R2 between 7 and 6. Then definitely you know that frequency is the respect of period. In your physics then, you know that whenever you're calculating for frequency, and you already have period. Oh, it's said to just take the reciprocal of it, and you're done. So in this video, I'm going to make sure that whenever you are designing anything again, you have your meter, you can actually measure the frequency of generating, because definitely when you know what you're expecting, when your meter is giving the reading, you won't be, the value is not correct. So the challenge some designers are having today is just move straight to the practical session. You just put resistor, you put capacitor, put LED, put battery, start blinking. What about the little theory behind it? So that if there's any fault, you trace it back to the equations guiding it. Alright, quickly. So the on state here is governed by 0.693 all in R1 plus R2 all in brackets multiplied by capacitor value. Here I normally like to stress this, very important, because when you're designing, capacitors are not usually common in some values. So what I recommend here is if you decide that your on state that day, when the welcome should come on, let it come on and stay for 2 seconds. Let's say welcome, welcome. If that's what you want, slot in two, the value number two, like 2. Write it where T on is. You now say equals 0.693 all in brackets. Then choose a particular value for your R2. Choose another specific value for your C and use R1 as subject formula. So by the time you solve, you get R1 as a value. Get this point I want to make. Even if the R1 is not a value that is common in the market, I recommend you do what? Switch the value to what? Variable. Let's say you solve and you're able to get, let's say, 3.3k kilo ohms as what? The R1 value. And looking for 3.3 is giving you an issue. You have, let's say, 5k variable. You pick it up, put it at between 7 and 8. Yeah, put it there. By the time you vary it, you watch your output, you vary it. When you get what you're expecting to get, you stop. That's how we design. So you don't sleep in the market looking for a particular value that is very off. But other ones can actually help out. So then once you can get your those values, definitely R2 is not a problem. Just slot it and get your off state. Okay. For the design you saw there, see the values I've used R1 10k, R2 220k, capacitor 10 microfarad, calculating your T on. This one is just elementary math. Just be slotting and punching your calculators and all that. 1.5 as T on, 1.59 seconds rather, 1.52 seconds as T off. You take your period, adding the two up. If you add it up, you have 3.12 seconds, just as what you saw on the flyer from the beginning of this video. Also, looking at the frequency as well, you see that it's just the reciprocal of the period, and the frequency of what you saw in that video is 0.32 hertz. What is the meaning of hertz? And that way to say hertz is per second. That's to say, in a second, that light is that welcome, it will be flashing inside. You will not notice anyway. It's not noticeable to naked eyes. It's going to do that for is doing that 0.32 in a second. So that's the science behind that. Okay, conclusion. Just pick these values, start your design. Now you have a proper guide, and drop your comments, please. Please, this video has a lot to offer. As long as you guys can subscribe, share, like. I promise you, just be recommending what you want me to design for you, and I promise to do that. As long as I see my subscribers increasing on daily basis, you're my what I say now, you're my motivation, and you're my drive to do more. Please, it doesn't take much to click that button, and you see me doing better. So this is a shaky diagram. Just follow it up. This is, the work of the transistor, because you see this wacom now is just for one LED. And the circuit is described. But when it comes to the main design, you are going to use several LEDs to form the wacom. For instance, look at it. So you open holes. Depending, in this case, double LEDs were used. You may decide to use single. Is the cost now. So you can use single to reduce cost. So, but the point is, I connected the LEDs in what? Parallel. I know that connecting in parallel, they may not have equal current, but let's just start it as a beginner. I know that maybe when you are now proficient, you can actually do series, which is just anode to cathode. You do it depending on how many you are using, and maybe you may decide to, in forming Wacom, you may decide to go what we call strands of series LEDs. Maybe if to design Wacom, you are having, let's say, 18 LEDs. So you're going to run them, let's say, three in series. You now parallel them, but each series strand must have a resistor that will limit the current. Then you do your, if you are supplying, let's say, the 12 volts, you can actually do 12 volts minus. If each LED is taking 2 volts, you do 2 times 3, that's 6. You now do 12 minus 6, you have 6 over 20 milliamp, because each LED will we take it to be like the professional current to use as the forward current that will make it at least show very bright is 20 milliamp. So you divide the 6 by 20 milliamp. Whatever value you get becomes your what? Your resistor value for that string. Three series string, three series string, three series string, three series string. Form it up to 3 times 6 is 18. So that means 18 of that value of resistor you have calculated. But as a beginner, run parallel first. Yes, run parallel, use 5 volts. Running parallel is that as you open the hose for welcome, like this, when you are forming the W, make sure that all the anodes are together, all the cathodes are together. That means you are having two wires coming out. You go to E, all anodes together, all cathodes together. When you are done with the last E, the welcome now is ready. That means you are going to have how many wires? That's 14 wires, 2 from each later. Go and link up all the cathodes, link up all the anodes. You are now having 2 wires. So take anode to the emitter of the what's it called? The TIP transistor is an NPN transistor. Remember the NPN transistor, the way it works. Let me quickly show how it works or how to read it actually. If this is TIP transistor, when where the road TIP is facing you like this, if it's facing me now, you count from left to right. Counting from left to right is BCE. We go to the anode. Remember, the cathodes of all the LEDs will be grounded, and it will have a common ground with your 5 timer circuit. And you're good to go. You're good to go. So, basically, that's the design. So, you mustn't put this buck converter. You mustn't put, if you even watch here, I just use 5 volts to power it. Look at it, 5 volts. You mustn't use buck converter. Let's quickly. You can see me now. Let me cut it off. I will not be like, can you see it now? So, just USB cord, no battery. Nothing, so no battery. Let me plug it there. Can you see it? Let me off this light. That's beautiful then. So, this is so 5 was all in parallel. So, when you're already good at all this way of designing, you can go for series connection. If you recommend in the video, you actually watched and you're okay with the video, just recommend in the what's it called, the comment section that I should do series for you guys. I will do it immediately. So what else is remaining? Okay. Just as I said, you can use to form any word of your choice, birthday something, office name.
Hello guys, welcome to Mechatronics, where we turn tech concepts into working systems. Okay, for the beginners outside there, secondary school students, even those in primary, are not left behind. Here I just have a very nice and simple design for you. What does this do? Let's see how it goes. Let's see how it goes. Wow, it's lovely, man. It's lovely. And guess what? With just $2 you can get this done. Less than $2 you can get it done. And how does it work? How does it go? How can we achieve this? Number one, you need to decide what you want to write. Do you want to write welcome? Do you want to write your name? Do you want to write the name of your business or whatsoever? I will leave that for you to handle, depending on what you want to write. So after that, you now pick up a plexiglass of this kind. You can see mine there. Then you mark out your dimensions. The dimensions you give will determine the height of your letters, the spacing. You may decide to go for 2 cm, 3 cm in between the letters. Then when it comes to if you're writing two words, maybe you are welcome. After writing you now make a bigger space in between you and R. Then R and welcome. I'm just giving an instance. So, but in this case now, I just designed only welcome. So you use your drilling machine after marking the dimensions. You use your drilling machine to open holes. Since I used 3 mm, I recommend you also use 3 mm bit. Use 3 mm bit for this drilling machine to open the holes. But in a case where you don't have access to drilling machine, why not make use of your soldering iron and open the holes carefully. But when doing that, you can also wear your nose mask because the smoke that will be coming out. I'm just talking to beginners who don't have complete tools yet. So after that, you paint. Use your spray paint and paint it so that you can see my own is black. Then after painting, you start picking your light emitting diode. Light emitting diode for short, we call it LED. You can see it here. This is a 3 mm size LED. This is a red color. I will quickly show you how to identify the anode and the cathode. If you look at it very well, you see that a particular terminal is longer while the other one is shorter. The one that is longer is the anode, that's the positive. The one that is shorter is the cathode. But in a case where you are taking it from another system where it's been used for longer and it's not a new one, unfortunately the two terminals are equal. Let's give an instance in this case now. No, they are equal in height. So what can you do now to differentiate? You can't use it whether higher, bigger or shorter or to identify right now. What you do is look inside the head. You see a smaller head and a bigger one inside. So the smaller one is the anode, while the bigger one is the cathode. So having said that, you start inserting your LEDs. You insert it. You put all the anodes one side, all the cathodes one side. As you are forming them, when you put it, you just drag the anode this way, drag the cathode that way. You pick another one. What I'm doing now is called parallel connection. Parallel connection in the sense that anodes are going together, cathodes are going together. So once I'm done, what do? I do it this way. Link all the anodes together, then use your soldering iron to solder it, which is not hard. So at this point, when you are done with the first letter, you move to the next one. So for instance, what you have here as welcome, all the anodes of this letter W are together, all the cathodes are together. All the anodes of the letter E are together, all the cathodes of letter E are together. Likewise, L, C, O, M, E, all of them. So at the end of the day, you are having, let's say, 14 wires. But in those 14 wires, because I want to use have timer to drive it, what I did, I took all the cathodes together and brought out just one wire, where you now limit with just a resistor before you ground it to the common ground. So after that, you have to join all the anodes too, but they are not going to VCC straight, because if you do that, you won't have the feature we are trying to add with the IC. So you can see the 7 wires here. They are the anodes. Anodes join together for E, or the anodes join together from M, or the anodes join together from O, likewise to the W. And at the end of the day, you're having, I join them together here. They are now having one. Um, you take that anode, that's what the transistor will be what amplifying. Quickly, I explain what we have there. We have few components that I've used. This is 55 timer IC. This is electrolytic capacitor 1000 microfarad by 25 volts. The 25 volt is that wherever you are putting it, it shouldn't be more than 25 volts. But in this case here, we just have a 5 volt system, so that one is settled. Now for R1 value, there is a resistor connecting pin 7 and 8. You have just 100 ohms. Then from 7 to 6, you just have 1000 ohms. Remember that 2 and 7 are going together. 4 and 8 are also connected together. Your output comes from pin 3, which the circuit I'll be sharing within the description section. We tell everything, just look at it and design it. So to make the video shorter, okay, this is very important, buck converter. This is a LM2596 buck converter. And what do we do? There's a potentiometer here where you use and vary the output you want to get. So having done this, this one is giving 5 volts already to the system. Let me quickly show you how to get that done. This is another of that kind. It's another of that buck converter. I take my meter probes. What I want to do, I want to reduce the voltage to 5 volts because you can actually supply up to 36 volts to this guy, this LM2596, and it will take it. But what matters now is that you need to step it down to what you want. In this case, I need 5 volts. I don't need 24 volts. I don't need 12 volts. You will spoil the whole design. Your design will damage. This is a 24-volt adapter. So what I do now, I plug it in, turn on my multimeter, and I plug it. Let's see what it will give us. Wow, 20.8. That is a default value from the manufacturer, so we're not bothered about that. Let's now vary. So when you want to decrease the voltage to what you want, you have to move anti-clockwise. Can you see how it's decreasing? 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6. You start doing it gradually because you're approaching 5. You're approaching 5 or 5.0, 4.9. Even at this, it will work very well. It's just like we're trying to look for perfection if actually it exists. Okay, I think this is better. This is better gradually. We are almost there. So I think we can go with this. We can go with 5 points or 4.9. Exactly. So let's go with this. So that's exactly what I did and powered it. So I just did this for the sake of clarification. Now quickly, the transistor you see here, as I said, is a BJT. Exactly TIP41. That's the one I use, TIP41C. And when it's facing you this side, that place the road TIP41C. When it's facing you, the way to count it is from left to right. That is BCE, base, collector, and emitter. Base goes to pin 3 of the first timer through a biasing resistor. I use 1K. Then the collector is what takes the VCC and amplifies the current before sending it to emitter for our LED anode terminals to receive. That's why if I should remove this transistor now, you see that the light will not be bright enough. So with the circuit diagram I'll be dropping in the description section, definitely even a primary school student should be able to get this done Remember, I said this is less than $2 to implement. Please share to your students. If you're a secondary school teacher, share to your students. You can design any letter of your choice, name of brand your office name, brand your business name, even put whatever you want, just encrypt it and let me help in any way you get issues along the line. You can reach me from the links I'm going to drop on the description section. Okay, quickly also do something again. Please don't forget how to support us is you subscribing, you sharing, you commenting. Ask your questions in the comment section. I will address it. I'm always there to address it. Thank you. And see in the next video, I'll be using programming method to drive this, and to be bringing better effect than this. But you need to count one for the count two. Thank you. Turning tech concepts into working systems. Bye.